So we're given some information, angle, side, side, and just a note on that, when we're given an angle followed by a side and another side, we get what's called an ass triangle, which means, oh, ass is a bad word, this could be dangerous. And it's a little dangerous in that there's two possible solutions here. And so I'm gonna attempt to draw this out and see why that might be. So I'm gonna draw a baseline. And then I'm going to draw a 45-degree angle from that baseline. And 45 is a pretty easy angle to draw, especially on this tool. There's my 45-degree angle. If it was less than 45, make your best guess. If it's greater than 45, make your best guess. So I highly recommend drawing these on paper when you do them. Okay, what else do I know? I know that, let's see, that's gamma. Oops. Gamma. And so side C has to be opposite gamma. And then they give me side A here. And so I'm going to put side A up here for ease of drawing. And they say A is 7. And so C is going to be 5. Now, let's see, what would 7 be around? Suppose we use unit lengths 1. A diagonal like this is what, about 1.4? So 1, 2, let's see, what would 7 be? Let's say it's more like 1.5, and then we'll adjust. So that would be like around 3 here. 6 would be up here. Is that right? 3, 6. Yeah, so 7 I think is going to be around here if I let this be 1, 2, 3, and so forth. Because this one diagonal there is the square root of 2, which is about 1.4-ish. So I think that's about 7 right there. Now, if you look here, coming straight down, 1, 2, 3, 4, 5, it looks like 5 is the hypotenuse, but it's not quite. So I think my 7's in the wrong spot there. Oops, let's see. I can't really undo that, can I? Nope. So maybe I'll just make a new line. 7's probably more like right here. So that's my point of interest. And when I drop a perpendicular here, what I'm going to find is it's slightly less than 5. So if I draw a horizontal line there, and oops, that's not a good horizontal line. And one question you might have is, well, how do you know that's less than 5? Because I'm just kind of guessing at my side lengths there if I draw that. Oops, having pen troubles today. I draw that right there. The reason I can tell you what that length is going to be is just from some basic trig we learned before. We know that this angle right here, angle gamma, is 45 degrees. And if I'm calling this length right here the height, what trig function relates this height here to that diagonal over there? Well, that's opposite over hypotenuse. That would be the sine. So what I know just by looking at this picture is that the sine of 45 degrees is equal to the height over 7. Or I could solve for the height. The height has to be equal to 7 times the sine of 45. And I know that the sine of 45 is the square root of 2 over 2 times 7. And if we check that number on a calculator, seven times the square root of 2 over 2, I get about 4.9, right? So it's a little less than 5, like I was believing it was. All right, so what does that mean? Well, the side I want, side C here, has to be out here from that point, and it's got to be length 5. So length 5 can't come straight down, which means it's either got to come out that way. Let's draw a straighter line. It's either got to come out this way here, or it's got to come out that way there. So there's two possible triangles I can get here. One of them, right here, has an obtuse angle, and the other one has an acute angle. And both of these triangles match the given information in that they have a 45-degree angle here, they have a side length 7 there, and they have a side length 5 here. And that's the given information. So we're going to have to do this, find the acute angle, we're going to have to do it again, find the obtuse angle, and then go on. Now, I mentioned a warning with the law of sines. Law of sines uses the sine, and the arcsine only knows about acute angles. So if we apply the arcsine directly, it's only going to tell us about this one right here, and we got to figure out how to get the other one. So let's do it. All right, so let's see, what should we do first? Well, we have C, angle C and side C, and we have A, so let's go for angle A. So law of sines says the sine of angle A divided by side A, which is 7 here, has to equal the sine of angle C, 45, divided by side C, which is 5. Solving for sine of A, we get sine of A is equal to 7 times the sine of 45, which happens to be a relatively nice number we're familiar with, divided by 5, and then angle A has to be the arcsine of that. And again, we know the arcsine only gives angles between negative pi over 2 and pi over 2, which means it's going to be the acute angle. It's going to be this one right here, right? That one's narrower than that wide angle right there. So we're going to get that one right there. Again, I want to think about this on a unit circle, at least the arcsine. Forget about the rest of the problem for a second. So sine is a y value. So maybe we're going to get y is equal to, let's see, some number up here. Something doesn't look right here. We'll find out in a second. And that y value either leads to that point there, or it leads to this point over here. This point here leads to this angle, which is the one the arcsine knows about. But there's this other obtuse angle from over here. I'll choose a different color to show that one. This obtuse angle right there. And it turns out that obtuse angle right there is this obtuse angle right here. And to get that, I just note that my arcsine here, let's call that theta, that's the reference angle here. So that bigger angle right there has to be pi minus what the arcsine tells me. So that's the other angle I want. So once I find this one, I know the other one, and I can do either of these triangles with that. And that's the hard part. Calculator. So let's see, we have 7 over 5 times, yeah, that does not look right. Did I make a mistake here somewhere? Oh, I messed up my A's and my C's, didn't I? Let's see, this should be the sine of A over length A, and no, A is 7. Okay. And then the sine of angle C or gamma over C. Okay. Why does something not look right to me? I don't know. Let's go to the calculator and find out. All right, so we want the, first I'm going to just calculate what that number is. So that was 7 times the sine of 45 degrees. And let's make sure I'm in degree mode. I'm not. And then we want to divide that by 5. And we get 0.9-ish. And then we want to take the arcsine of that whole thing. Now, I really don't need that number separately if I look back at my notes, but I just wanted to double check there. Yeah, so we don't, that's the value of the sine. We don't need that. We need the actual angle. So I'm just going to back up here and take the arcsine of that fraction. And I get an angle of 81 degrees. Let's just round it for 82 for ease. We have the actual value there, and that is what, angle A here. So I'm going to call this capital A, and we're going to call it around 82 for the moment in the notes. We'll come back and get the better value when we need it. Oops. here. So this angle is about 82. Approximately 82 degrees. And that's pretty steep. So would you buy that that's 82 if 90 is straight up and down? And my picture's not perfect. And again, this picture is a little bit better. And I think this angle right here is about 82 degrees. Oops, degrees, about. And once I have that angle, I have the top angle. So if this angle right here is 82, then all I have to do is do 180 minus 82 minus 45. But again, we'll use a better value for angle A there. So now we know angle B. So angle B is equal to 180 minus the given 45 minus that new angle, which is the previous answer on your calculator, or if you're doing it like I am at Desmos, just type an A there, and I get 53 degrees about. Does that seem reasonable? Yeah, that seems reasonable. That looks smaller than 45 to me. So I think that angle is about 53 degrees there. And then now I can find this length B pretty easy with the law of sines there. So let's do that one. So I'm working on the acute version here, and I have this one right here to 2 decimal places is what? To 2 decimal places, it is 81.87. See, is that right? Yep. 81.87. My angle A, they're calling it their alpha 1. And then this one would be 53.13 to 2 decimal places, my beta. And then side B, we can find with the law of sines. So to do that, we're going to go back to this given information here to get side B. And so we'll say side B1 over the sine of angle beta 1, which we have on the computer, on our calculator, is equal to our C equals 5 over the sine of 45 degrees. And so we just need to multiply the sine of B up here. And that is our length B. So let's try that on the calculator. So my length B, which I don't need to name because I don't need to reuse it, is going to be equal to the side 5 times the sine of my previous answer here. So take advantage of that previous answer on your calculator, divided by the sine of 45. Let's double check that I typed it right and I have the right mode. Right mode, yep. And did I type it right? 5 sine of beta or B over 45, yep, did. And so I get it's about to 2 decimal places 5.67. So that's this one right here. Now for this one down here, I mentioned that the other obtuse angle I want is pi minus the acute angle I found. So for this one right here, I just need to go to my calculator and calculate pi minus that alpha 1 that we found. So pi minus that about 82. Oops, we're in degrees, sorry. So in degrees, pi is 180. So 180 minus that alpha 1 that we found. And that's going to be the new angle. And then I just repeat the last 2 steps to get the next 2. So let's check that. All right, so this is going to be, I'll call it A2. And it's equal to 180 minus my A1, which I just called A here. So if you have a calculator with a previous answer button, then you would have to basically retype that if you didn't want to worry about rounding. So I'm getting about 98 degrees. for that angle, just a little bigger than a right angle. And then the next thing we did to find angle B is we knew that the angles had to add up to 180. So to find my B2, I just repeat that step here, take my 180 minus the 45 I was given, minus my new angle 2. And so I'm going to get the other angle has to be about 36.87. And then the work here is similar. I just have a new angle to work with. So I can get that pretty quick here too. It's exactly the same work. It's just going to be 5 times the sine of whatever angle B is, at this time, and that's my B2, divided by the sine of 45. Parentheses, please. And so I get that should be about 4. So let's look at the picture and think about if those last 3 results seem reasonable. So we think about 98 degrees, about 37 degrees, and a little bigger than 4. So that would be this one right here. So I'm thinking this angle right here, better drawn up here. That angle right there, I think that's about 92 degrees. This angle right here, I'm saying is about 37 degrees. And then this side right here, I was thinking was just a little bigger than 4.24. My picture makes it look pretty close to 4, which means my picture's not too bad. 4 versus 4.24 in that rough sketch, I'll take it. Yeah, that seems reasonable. So I do think it's worthwhile to try to draw these pictures to the best of your ability with rough in the angles and the side lengths. And a ruler and a protractor would be awesome if you have one. If you don't, Bimart sells them or Walmart sells them for like, I don't know, $5 for this cute little kit for geometry. Oh, I've got one right here. Like maybe you've seen one of these before. Let's stop share for a sec. Turn on my camera. Hello, camera. So here's my cute little, I think this cost me like, this has got a lot of stuff in it. So this one was like maybe $10, but you can get them for like $5 at Bimart and Walmart in the school supply, office supply section. All right, back to this. And then the other thing I'll share in this video is I drew a picture of this in Geogebra where I can adjust the angles and the side lengths. And so I set this to be a 45-degree angle. I set the opposite side to 5 and then the other side to 7. And my picture shows me there's 2 possible answers here. Let me move those. All right, the angles are sitting on top of each other. I'll fix that. But I can see one of the sides here is about 4.24. The other one was about 5.66, which are the numbers we calculated before. So it is possible to use geometry software, which is like using a protractor and a ruler, to draw these out to double check. And I highly recommend you try that. All right, that was a tough one.